anywhere, any data you pass through it or you get from it, it's associated to that particular vector, like that string of numbers, I would say. So through all of these calculations, it decides on the most probable output in the output layer, and that's what we see today as an output to an LLM. And this is how our brain works also. So this is a very simple diagram of a simple neural net. So when you add data, so let's say you ask an LLM, how do I cook pasta? Let's say, right? Simple question. It has to give you step-by-step answers, right? So each word has a weightage, and each next word. So if you say, how do I cook pasta? What is the next word that is most probable after that? So each of these dots that you see here, they're called weights, and so each of them have these, they're called nodes, and each of these nodes have weights. And when your information passes from one to the other, the weights get multiplied, and there's a probability that it goes to the next node. Finally, it goes through millions of these nodes, and it finds one node where it should output from, and that's assigned to a word. So that's how neural nets basically work. And the way they do it is, so these are all nodes, and all of these computation of weights and all have to happen by numbers. So when you input, so if I say, so in our previous example, the sky is blue, right? So it doesn't, an LLM would not understand text, it would understand only numbers. So the sky blue, each of these words would be converted into a thing called embedding. So an embedding, this is a really important word in the LLM and data science and AI training world. So embedding is a vector representation of a word. So the the word the has a particular vector associated to it, and anywhere, any data you pass through it or you get from it, it's associated to that particular vector, like that string of numbers, I would say. So through all of these calculations, it decides on the most probable output in the output layer, and that's what we see today as an output to an LLM. And this is how our brain works also, right? It starts thinking in steps. It just happens so fast that we don't know how it's doing it, but this is how our brain also processes information.
So there's a memory that is connected, and then that fires up something else, and then you repeat.
Yes, exactly. Yeah, yeah. So each of these memories have a certain. So maybe. So that's why people also have biases, right? Us as humans, we also have biases. For example, if somebody doesn't like spicy food, it's probably because there have been 5, 10 instances in the past of them, getting burnt or eating something super spicy, right?
Yeah.
So that's essentially how a neural net, an LLM or a neural net also works, similar to our brain. And I mean, when it started over the last 15, 20 years, of course, we still didn't know how to really reach the level of our brain, and I don't think we still haven't reached the level of the human brain, of course.
Yeah, 100%.
Yeah, yeah, but of course, it's gotten a lot more uh, dense. I would say there are a lot more dense neurons in today's LLM. So you must have seen before when GPT-3 and similar models came out, they used to talk about parameters. So million parameters, billion parameters. So each occurrence of a word in a certain scenario is a parameter. So each of these nodes would sort of be like a parameter.
You're right. So the
Yeah.
context was important of that word, where it is
Yeah.
used. What's the
Yeah.
context?
So the context is determined based on where in the sequence it is used.
Right.
Yeah. So that's basically how it's a lot of I would say it's a lot of small calculations happening very fast. It's not very complicated calculations. Usually like some point something into some point something, but it just happens at a large scale, and that's why we need compute, right? That's why GPUs are so valuable today, because they have like 800, 900 cores. So each of these cores can do one of these calculations per millisecond. So yeah.
So interestingly, we spoke about the neural network, the node, and also why GPUs are important and how this compute happens, which is a good point. Let's say, how do we store this data? Let's say you said something about vector, and you
Yes.
had LLM. Like now, this large language model, I'm sure this is not a file, or if this is file, how is it stored? How does it interact? How does it know that I have asked something, or how does it respond back? What is this whole thing about? Is it code? Is it some sort of a database where you can interact with? What is it? Why,
So
as a
so it's not code, right? I mean, so there's no lines of code you would associate with it, but it would be like it's basically a model file with all of these neurons and nodes present, and it's able to use hardware like GPUs to create to calculate these probabilities, and finally it outputs certain list of numbers. So you would have so if you ask a question on ChatGPT, it gives you a response with 100 words. So each of these words will have a vector associated to it, and then it would compare these vectors to its like a dictionary where okay, this vector is this word, and it would basically give you the output. So this is like it's like a big calculator essentially, just doing a lot of calculations all the time, outputting certain probabilities. Those probabilities being converted into vectors, vectors converted into words. Same for images as well. Yeah, we're talking only about words, but what it does with images is each image has pixels, so it's basically predicting pixels instead of words. And audio is each it has a pitch and a wavelength, and you know
And
yeah.
since everything is digital, it is at the end of the day zeros and ones.
Yeah, exactly. A vector is basically just not zeros and ones. I mean, but yeah, it could be minus 36, minus 35, 5, 10, 12, 15. So like a sequence of random numbers. So that's what a vector is, right?